In a previous tutorial, I demonstrated the usage of the context package by creating a simple proxy-like server. It simulates forwarding requests to another downstream server. Depending on the user ID, if the ID is below 100, the response of the downstream server takes up to 1000 milliseconds. If it is higher than 100, it only takes up to 200 milliseconds. What I didn't mention was that I actually didn't have to create a new context using context.background. In Go, an incoming HTTP request already has a context that can be accessed directly. What I'm trying to demonstrate next is often referred to as HTTP Context Propagation. I deleted the code for the context timeout on my server and basically moved it to the client. The client code is displayed on the left part of the screen. Note that in the client code, I used the request with context function to create an HTTP request with a context. I will change the ID and the timeout constants of the client throughout the video from time to time. Just like in the previous tutorial, you can see that the response times for higher IDs are below 200 milliseconds. However, for lower IDs, the client prints an error. It says that the context deadline was exceeded, while the server tells me that the context was cancelled. This means that somehow the context signal was passed from the client to the server. If this was the case, what about context values? If the whole context was really passed to the server, I should be able to write them on the client side and read them from the context on the server side. Let's try this. I'm passing the client context to the withValue function. Also, I'm using user-id as the key of the context value and the ID as the value. In the server code, I'm just using a simple print statement to access the request context in order to print out the value of the context. The print statement would deal with the type of the context value automatically. The server should print the context value right after the user ID from context string. Of course, only if it receives a request with a respective context key. As you can see, it does not work. The server does not receive a context value and therefore the context value is nil. All right, but how did it work with the context signal before? Actually, the context will not be sent across API boundaries or over the wire. It will only be passed around inside a process. Here, the context of the client timed out. The Go client library recognizes the timeout since the request was created with a context and passed to the do function. So, the client will close the connection, which in turn will be registered by the server. So, in order to parse values across the wire, you have to write the respective code yourself. Usually, this is not a problem. So far, I have used URL parameters to send the ID from the client to the server. Another common alternative are HTTP headers. As you can see, I'm already modifying my code for the client and the server, so that it uses headers instead of URL parameters. By the way, please consider liking the video or subscribing to the channel if you want to support the creation of more videos like this. As you can see, I used the header.set method for setting a header on the request. Also, I used the integer to ASCII method to convert the integer to a string. For the client, I don't need URL parameters anymore. Therefore, I removed them from the URL. Finally, on the server side, I got the respective request header instead of the URL parameter. As you can see, the code works like expected. I'm showing you this tweet because I think it sums up context propagation pretty well. Please let me know in the comments if you agree.